it's all set up. Perfect. Thanks for setting it up. Welcome from my side. Great to see so many people here once again, both old and new, right? So I appreciate that every year you take the time to come here and listen to all these things we have to say. And of course, I have to do a call out to the statistics. So fellow Austrians, we're at number 4 now in the top 5 attendance statistics. So fellow Austrians, that's worth a cheer. Let's switch course and go a little bit into what we'll actually do next. Spring I/O is always at this particular time of the year, right? It's like half a year before we do major Spring Framework releases, actually, because we usually do them in November. So here it is once again me talking about what we intend to deliver in about half a year's time. And this will be a major generation. It will be Spring Framework 7.0 and Spring Boot 4.0. So after like 3 years, we take the opportunity to do a major baseline upgrade in particular. After Spring Framework 6.0, 6.1 and 6.2 in the past couple of years. So where are we now? Just revisiting the current baseline. We have a well-established arrangement, JDK 17 baseline, Jakarta E10 focused. We do lots of things across the code base with the best tools we had at the time. We use a custom nullability arrangement. We have Kotlin 1 integration. We had a strong theme, GraalVM native image support, Spring AOT support in Spring Framework 6. And we did actually pick up the virtual threads topic midline in Spring Framework 6.1 when JDK 21 came out, right? So our major generations are not an exclusive way of delivering major new platform features. We do them whenever they need to happen, right? This can be midline, and in this case it was in 6.1. So just comparing these two, there's quite a few things we do to the Spring Framework 7 baseline. We upgrade to Jakarta E11. We switch our nullability arrangement to the recently released JSpecify ecosystem consensus, a way of doing it. I'll be saying a little bit more about it in a minute. We upgrade to the latest Kotlin 2 generation of the Kotlin language. So our integration is going to be exclusively focused on the best possible way of doing it against Kotlin 2.x. So we're going to track the latest releases that Kotlin does. We always set up a new generation for tracking what will come next. So it's not only a raise of the baseline, it's also preparing ourselves for picking up further evolution from there. We, of course, keep up GraalVM support, Spring AOT support. We actually reinvest into it with an additional focus on Project Leyden, on everything you can do with the hotspot JVM in terms of making the best possible use of AOT opportunities, ahead of time computation, processing opportunities. So there's lots you can do now, in particular against JDK 24, JDK 25, with the hotspot JVM, where our AOT facilities and our general approach towards AOT is a very nice complement. And last but not least, virtual threads have actually had kind of another boost in JDK 24, relaxing the synchronization requirements. So now is the real time to consider production adoption for virtual threads across the ecosystem. So huge opportunities there. One thing to note, we haven't actually raised the JDK baseline. It's still JDK 17. That's very intentional because there's industry consensus around JDK 17 in many ways. However, JDK 17 isn't even on that timeline, right? We actually we currently are in 6.2.x against JDK 24 being out. By the time Spring Framework 7.0 goes live, JDK 25 will be out, and that's already the next long-term support release of Java. So we may have a JDK 17 baseline in case you're being held back from upgrading your Java platform generation. However, we strongly recommend upgrading to at least the latest LTS release of Java whenever you perform a major Spring upgrade. So Java 17 may be the baseline, but there's so much goodness beyond Java 17, in particular in the recently released JDK 24, naturally picked up in the upcoming JDK 25 LTS. By all means, make use of it. I would go as far as, if you're currently still on JDK 17 and you're considering a major upgrade like in half a year, go straight to 25, skip 21. There's so much goodness in even between 21 and 25 worth picking up. So much goodness that you'll naturally benefit from without any change to your applications that it's hard to ignore. So strong recommendation, consider a JDK 25 upgrade along with your Spring Framework 7 Spring Boot 4 upgrade. Back to Jakarta EE for a moment. The most interesting specifications we're tracking Servlet 6.1, JPA 3.2, Bean Validation 3.1. They are a natural upgrade for us, right? So we also want to prepare for the further evolution of those specifications beyond that point. So this is going to be the minimum in Framework 7 and Boot 4. And Jakarta E11 actually agrees with our JDK 17 industry consensus baseline. However, specifications are only as good as they're actually being implemented in providers to use out there. So our real interest, frankly, is in the concrete providers for Jakarta E11. Tomcat 11 already being out, Hibernate ORM 7 being close to general availability, same for Hibernate Validator 9.0. So you'll naturally find those default providers of Servlet JPA Bean Validation in your managed setup eventually in Spring Boot 4. Not only that, we actually take the opportunity to revisit a couple of other key open source dependencies we have out there. The most important one, the most significant one, being Jackson 3, that recently landed in the latest Spring Framework 7.0 milestone. Jackson has had a long history of 2.x releases, but there is now a Jackson 3.0 release coming up, being imminent, that we intend to pick up. So it's rolled in already. There's definitely the opportunity to use Jackson 3, but depending on the pickup in the ecosystem, there's a strong recommendation coming along with it that you actually should be migrating to Jackson 3 as soon as you can, preparing yourself for the further evolution of the Jackson 3.x line. There's also Netty 4.2. After a really long series of Netty 4.1.x releases. And there's JUnit 6 coming up in autumn this year. So all of these are of huge interest to us as well, and we consider them for basically a redefined baseline in Spring Framework 7, even if we might, in some cases like Jackson 2, keep up some support for the previous generation side by side. We consider them part of our new baseline definition. A word on JSpecify in all brevity. There's a separate talk on this, a dedicated talk on this tomorrow. JSpecify is a set of annotations for declaring nullability in your API signatures, in our API signatures. It was natural for us to pick this up because we already had, at Spring Framework level, a very consistent arrangement with a non-null by default policy and exceptions being declared with @nullable. JSpecify actually improves on that because we have type use annotations where you can even annotate nested types and generics. So there's this. It's actually the first major use of the type use annotation feature in the Java language that I'm aware of. So the deepest use at least. So that's a significant migration for us, hopefully not too significant for you because you can mix and match old nullability annotations with the new ones, but also a strong recommendation if you want to make your application setup, your API interactions more null safe, consider adopting JSpecify along with Spring Framework 7. Yeah, and this is all the best you can do at this point of time. Project Valhalla in the JDK is actually going to deliver some, well, inclusion in the Java language, null-safe declarations, null-safe type declarations within the Java language itself. But that's a topic for another day. The best you can do to prepare for it, to prepare for the further evolution of the Java language in that direction, is to adopt JSpecify now. Kotlin 2, also quickly mentioning that there's quite a few things we can do and that we work with JetBrains on improving the efficiency of reflection against Kotlin. There's a lot of goodness in Kotlin 2 that is worth picking up. So for Kotlin developers, this is a huge upgrade. And for us in Spring Framework 7, it's a huge opportunity to improve the integration that we have with Kotlin facilities at runtime to make Kotlin an even better first-class citizen for Spring application development. All right, so that's where we are, and that's already all I have for you for this very moment. Spring Framework 6.2 and the recently released Spring Boot 3.5 is where things are at now. And there's a lot of stuff in this that's worth picking up, that's worth digesting, that we can't even mention here. Coming up next is Spring Framework 7 Spring Boot 4.0 in November this year. Keeping up the JDK 17 baseline, strongly focusing on the best possible runtime story against JDK 25 when running on it. We have the Jakarta E11 topic, Hibernate 7, we have Jackson 3, Kotlin 2, JSpecify, aligning with Project Leyden. There's a lot of platform-related effort going into Spring Framework 7. But let's not forget that, of course, we also work on programming model features, bean registrars to be mentioned in my breakout later today. And you'll hear actually more about other Framework 7 topics, even on this keynote stage, for example, API versioning. So talking about breakouts, just for a moment, that's my dependency injection revisited breakout this afternoon. But in particular, tomorrow, we have a JSpecify breakout from Sebastian tomorrow morning. And we have a dedicated Kotlin session, a Kotlin 2 session, tomorrow afternoon, also by Sebastian. So highly recommended. All right, that's all I had for you from my side. Next up, you're going to hear about also Spring Framework 7 related web topics from Rossen. So Rossen, the stage is yours, wherever you're coming from. Oh, there he is.
Morning. I'm Rossen Stoyanchev from the Spring Framework team, and I'm here to talk about a couple of upcoming features in Spring Framework 7 for your web applications. When it comes to remote HTTP access, you can work with HTTP directly and use the REST client, the web client, or the REST template. Or you might prefer to use a Java API. For this, you can create a Java interface that expresses the details of the HTTP exchanges, and the rest can be automated. Historically, this has been the domain of Spring Cloud and OpenFane, but as of Spring Framework 6, we have that option built into the Spring Framework, so you can create HTTP exchange interfaces. And all that you need to do from here is to configure the client that should be used, because we still need to use a client underneath. And then you create a proxy factory, and now you're ready to pass an interface and get a proxy out of that, and that automates the entire HTTP exchange. So this is really great and actually a pleasure to use. But the next question is, how can we make this easier? Is there anything we can do in auto-configuration in Spring Boot? And this started out as an issue in Spring Boot, and for a while the discussion didn't really go anywhere, because it's not obvious at first what can be done. I mean, it takes just one line to create the proxy, so what can Boot actually help with here? The issue becomes more obvious when you begin to work with this and to create more of those interfaces. So for example, if you had an application that needs to use the GitHub remote REST API, then you might create a number of different HTTP service interfaces to manage issues, repositories, milestones, releases. Actually, the GitHub API is very, very rich, so you could easily imagine many, many more of these interfaces. Furthermore, you may actually have multiple different hosts that you work with, and there are interfaces for each one of those, and you can see how the configuration begins to grow and the problem begins to become obvious. In fact, if we look back at the configuration, and that would be repeated bean declarations for each one of those interfaces, it becomes obvious that this is just boilerplate. We shouldn't have to work with the proxy factory. We shouldn't have to create these proxies. What we're actually interested in is what are the interfaces that are going to be involved in this, and we'll declare them automatically as beans. And how do you want to configure the REST client that underlies these services? So let's see how this looks in Spring Framework 7. First, we need to identify the HTTP services. And we are going to declare an import for a group. And for those who are familiar with Spring Cloud and OpenFane, this would be essentially a service ID. The group name would be the service ID. And then we have a base packages declaration, which is pointing to a package that contains those HTTP service interfaces. And they will be automatically detected and declared as beans. That's convenient, right? We can create as many groups as we want, another one for the Stack Overflow API if we want to access that as well and get information from both places. And now we want to configure the clients for each one of these groups. Essentially, we create a configurer callback as a bean, and that lets us configure the individual clients through a filtering mechanism so we can target the clients individually. Here we configure each one individually, but we can also create a filter that targets all of them at the same time, which makes it easy to configure them together. Now, as simple as this looks, and there's a lot that I haven't shown, I do have a breakout session where I will speak more about it, but I just want to take a moment to say that as simple as this looks, the solution was really non-trivial to arrive at, and the implementation, as well as the design phase, it really took collaboration across multiple teams and knowledge from multiple teams, including the new Spring gRPC project, which actually has similar needs with lots of interfaces that need to be declared as beans that are generated, and there is a similar mechanism there as well. There's a lot more to show. There are Spring Boot properties for HTTP service interfaces, so you can do read timeouts, connect timeouts, very powerful configuration for individual clients all at the same time, so this is something new for Spring Boot, through hierarchical properties. And there's also built-in configuration already coming for Spring Security 5.0, excuse me, and Spring Cloud 5.0. So you can easily get OAuth, for example, as simple as putting an annotation on your interface, and you can get load balancing with Spring Cloud just by adding that configuration and specifying your services. I have a talk about this tomorrow, so if you'd like to learn more, please come to the talk. We have demos to see the actual code behind what's in the slides. For the next talk, for the next topic, HTTP API versioning. Now, this is an interesting one, and as often is the case, consequential features in the Spring Framework start with a user request, with a feature request. In this case, loosely paraphrasing, the feedback was, yes, it's possible to do, but it's not that easy as it should be, and that made us take a look and consider. Now, API versioning is one of these topics which is a bit hard to pin down. There is a range of opinions about whether you should do API versioning or not. And in fact, Roy Fielding says that you should not. Main point being that, if you use browsers, you don't see versions, so why should you have to version your application? Counterpoint, browsers and humans versus machine clients. not exactly a match. There is also no standard way to do versioning. There are multiple ways to do it, and each one has specific details. So that's another thing which adds a bit of a complication, things that you need to figure out. And last but not least, not all applications are the same. Some applications, the need for versioning never arises. So if you heard that common advice, version from the start, well, actually, you might want to actually see the experience as you go along. So there are good reasons why you should have first-class support and be able to introduce this and to have an idea of how to approach and think about versioning. And this is why we decided that we should put that support. And while it's not difficult, it shouldn't be something that everybody has to do in their own applications to work out how to do it. And it's, in the end, it turned out that there is plenty to sort out. I'm just going to show briefly how that looks. If we take those HTTP exchange interfaces that we saw earlier that we can do remote access with, we can now put a version on that, and we will add a little bit of configuration. For GitHub API, it's a header that we need to insert the version. And for the Stack Overflow API, it's actually in the path. So we can, as you can see, you can configure this once, and then as you use this, it will be automatically inserted for you. On the server side, we have support for controller mappings. You can express a version. There's a lot more to it. So that's something that we're going to talk about in a dedicated session. But you can see that in the WebMVC config and in the WebFlux config, you can configure versioning-related strategy details. And for that, I have a talk tomorrow. So please come to that talk if you're interested. And with that, we're going to turn to performance optimizations. I would like to invite Anna Maria Mihalceanu from the Java team. Please welcome Anna.
Thanks. So, performance optimizations. Great performance. I'm saying my name correctly. Very rare, by the way. Good morning, Spring IO. I'm going to warm you up for the performance optimizations that happen in Java that are also powering Spring Boot, as you have seen in Juergen's presentation. Now, we know that Java has favored peak performance for a long time, thanks to the hotspot JVM, which interprets bytecode and is compiling that dynamically for our application, based on how our application is behaving. But we also have observed that all that profiling and compilation takes time, and that time is sometimes translated in a slower warm-up and a little time extra for reaching that peak performance in Java. So, Project Leyden aims to figure this out. How? Well, we're actually targeting these two key metrics to improve the startup time, meaning the time that you're getting the first HTTP response for a web application, for example, and the warm-up time, the time to peak performance of the Java applications. And what's the trick to get all this done? Well, by shifting computation, either earlier in time, before your application runs, or later in time, after your application has run already. Or maybe you've waited entirely. So, how do you do this shifting of work? Well, there are two approaches. There's an approach to do that at build time, through static analysis, and also another approach to do that at runtime, through dynamic observations of training runs. Project Leyden is aiming to do both of these approaches on the long run, but in the big picture, we're aiming to first answer two questions. How far can we get without imposing new constraints on existing code, without making any specification change, without sacrificing any of Java's natural dynamism? So not changing anything. And also, how far can we get simply by leveraging existing hotspot JVM components? For now, this means that we're not doing any static analysis in the Leyden project, but relying solely on training runs to gather observations dynamically. In more detail, here's how the training runs are working. So first of all, we need to train, right? So training means recording observations of the applications in action, like which classes are loading and they're initialized, which methods become hot. And of course, all these results are being stored in a configuration file that you can see here in blue in the slide. Secondly, we need to assemble and convert these observations into a cache, and an ahead-of-time cache that we can further feed to our application at runtime, when we are profiting of these results and we're running our application with the AOT cache. Now, this kind of pattern in 3 steps, it's familiar to some of the people that have tried class data sharing, right? So this is what AOT work is, in fact. It's actually an evolution of CDS. So what exactly has Leyden delivered so far to the JDK? Well, JVM work that Leyden has done so far is quite a lot. You see here first load and link classes that was delivered in JDK 24 via JEP 483. All the other optimizations that you see here in the slide are also part of the Leyden AI prototype, and in time, they will be integrated in the mainline JDK. But how well does shifting work? Let's see some numbers. So these are the numbers of normalized relative performance for some frameworks. And because we're at the Spring conference, I will ask you to look at the right-hand side of the slide. And we'll start a little bit talking about for a simple Hello World application running on Spring Boot. Now, we're going to normalize as JDK 24 to be the startup time for 1. So the 1 there is like normalized for JDK 24. That's the one in the Hello World. Now, if we are running JDK 24 with the AOT features enabled, we get a significant improvement of performance of 62% for that simple Hello World. If we're running with the Leyden AI build with other AOT optimizations, we get an extra 9%. Quite impressive, right? But yeah, that's a Hello World. We do production applications, right, as developers. We deploy in production. So production means more real things. So we also benchmarked the SpringPad Clinic application. And we have also seen performance improvements there. So you can see that there's a performance gain of 31%. And with Leyden EA, there's a performance gain of 62%. But if you compare both of the applications, you're going to say, OK, but SpringPad Clinic has kind of a lower results compared to the Hello World. And there's an explanation for that. Well, guess what? SpringPad Clinic has more classes, so more things to compile. Pretty much like our real-world life. More things to compile, it takes a little time to deliver like performance gains. But they are there, and performance gains are there. These all are relative to AOT class loading and linking. So Leyden has already delivered a lot of compelling performance gains with more to come. And it does all that by remaining fully compatible with the Java specification of the Java platform. And to tell you more about how this works for Spring Boot in specific, I invite on stage Moritz from the Spring team.
Thank you, Anna. Hey, welcome. So, I'm going to grab the clicker here, and we're going to take a look at AOT cache in regards to Spring Boot. So, Anna already told us what greatness is there in Leyden, what it's to come, but stuff has been delivered in Java 24. So, what do you have to do to get it right now in your application, in your production? So, of course, you need Java 24. That's a starter. And we need Spring Boot 3.3 or later, because this has the necessary infrastructure in it to run it. And if we take a look at the SpringPad Clinic startup time, this time with absolute numbers, not relatives. So if you take a look at, if you just take the fetch jar, deploy it on a machine somewhere and execute it, you are about to start in 5.74 seconds. If you unpack it, it gets a bit faster. If you use the existing CDS support, which is in Java for like forever, you end up in 2.95 seconds. And then you enable the AOT cache, which is the thing which is new in Java 24. You end up in 2.61 seconds, which is already an performance startup factor of 2.2x, right? Just by doing a small training run, enable AOT cache, use JDK 24, and your application starts 2 times faster, which is awesome. If you then enable Spring AOT, which is a feature of Spring Framework to shift more stuff to the build time, it gets even faster. But that's not the end of the story. Like Anna said, Leyden there is more to come. So the amazing Java team is working right now on ahead-of-time method profiling. That means when you do your method run, the profiler, which is in the compilers, already analyze your application, and then they store this profiling data in the cache too. So that means when you then use the cache for startup, your JVM gets hotter faster because it already has profiling information. And there's also the idea of ahead-of-time compilation, which means why compile stuff with a JIT at runtime when you can also do it in the training run and then just store the compiled code in the cache and then use it on startup, which means your application does not only start faster, but it's also instantly hot. So if you take a look at those graphs, the blue is the baseline, and you see it takes about like 32 seconds to reach peak performance, right? If you enable AOT profiling, you reach peak performance at like 25 seconds already. And then if you also enable code compilation, which stores the compiled code in the cache and then reuses it, your JVM is instantly hot at like 8 seconds. So it's significantly hot faster, which means more requests per second handled earlier, which is, I think, absolutely awesome. Now take a look if we take the Leyden EA prototype, we compiled that JDK and run this pet clinic stuff against it. So our baseline is still 5 seconds. We unpack it, we do the AOT cache, we end up at 2.61 seconds. This is what you get right now with Java 24. And if you then apply the Leyden prototype, enable AOT cache, the code compilation and the profiling stuff, you end up at 1.4 second startup, which is a startup factor of 3.9x, which is already crazy. But if you then enable Spring AOT on top of that, you start this application, which took like 5.74 seconds, you start it in 1.29 seconds, which is a startup factor of 4.4x. Right? Let me repeat that for you. 4.4x, which is like 440%, which is like 4,400 per mil, which is 44,000 per decimil, which is 44 billion. I don't even know what the sign there is called. It's absolutely crazy. Okay, you get the idea. Okay, Leyden and the whole AOT stuff is absolutely awesome. So, thank you. If you want to learn more about that stuff and how to actually achieve that with your application, please come to my breakout talk. It's Friday at 12:30. We're going to take a look at Project Leyden, CDS, and I'm going to compare it also with the other existing technologies like RALVM and Project Crack. So that's it. If you're interested in that, please come. And with that, more performance talk. I'll invite to the stage Mark Paluch from Spring Data team. Thank you.
Hey, Barcelona! How are you guys doing? Do you enjoy Spring? I didn't hear anything. Look, I brought a little bit of reference manual in here, which says, enjoy Spring. So, do you enjoy Spring? All right. I'm Mark. I'm project lead of Spring Data. Moritz already set the stage regarding performance, and I want to stay in that realm for a while. Performance is very relevant to Spring Data. We make sure that your queries run the best way possible. If your queries run slow, then you and your application will have a pretty hard time. So we have that intrinsic motivation to keep overhead as low as possible, since Spring Data is built on top of drivers and persistence frameworks, like with JPA. And talking about JPA performance, there are two ways to run JPA queries. You have string-based queries, where you express the entire query as a string, where the JPA provider has to parse your intent, the entire query, and then run it. Or you declare your query through the criteria API, a programmatic API that has all the necessary details already available, no parsing involved, everything being provided as Java values. And Spring Data is a heavy user of criteria API, right? Everything of the area in derived queries is using the criteria API. Because one might think, that is the best way to run JPA queries. Turns out that assumption doesn't really hold true. If you run a string-based query, you get basically 6 times the performance of a criteria query. Right? This benchmark shows around a performance of about 100,000 criteria queries per second, clearly on an in-memory arrangement with H2. But if you decide to formulate your query as string, you get like 6 times the performance. And that is also measurable in production. If you compare criteria API against string-based queries, then criteria-based queries run about 25% slower on your Postgres, on your network database, what have you, right? Spring Data 4.0 gave us the opportunity to revisit our arrangement. With about 15 years into criteria APIs, we started exploring, would it be possible to render derived queries as a string? Turns out it is possible, and we liked the result very much, meaning that by upgrading to Spring Data 4, you get automatically the same performance for derived queries as with your add query. So everything is going to be on par. Clearly, if you are up to peak performance, then you would use the entity manager directly and bypass the entire repository business at all. And for you, that means you don't have to change a single line of code. You just upgrade in November to Spring Data 4.0 and get as fast derived queries as your add query annotation. And I think that is a pretty neat outcome of that exercise. We expect that one or another thing might break, as mentioned. We are 15 years into criteria API business, and it would be not a surprise to find a bug in that area. You can try out all those new bits already. There are milestones available from Maven Central. While talking about repository query methods, imagine you are in a debugging session. You're trying to invoke that innocent-looking method because there's something not just right in the behavior as you would expect it. Right? So the moment you step into the debugger, basically the gates of hell open themselves. As if some demonic lord would have written code to give you a very bad time, you land in invocation handlers, in interceptors, in advisors. And if you know which method not to skip, you eventually end up in a little bit of Spring Data JPA code. And then you think, yeah, I made it. I understood it. But looking really at that code, there's something about execute, parameters execution. Where's the query? There's no query. Well, there is, but you don't see it. The thing is, a framework has to be the kind of the exact opposite of what you would write in your repository query method before there has been Spring Data. Right? It has to support all sorts of functionalities, projections, streaming, running native queries, named queries, running derived queries, all that fun stuff, right? And so this code isn't there for you to be debugged. But what can you do, right? You can exit your debugger session and then set up SQL logging and try to correlate all the logs. That's not fun either, right? So that's not great, right? You rather wanted to have the optimum for debugging a repository query method. Something that displays you what is the query, what are its parameters, and how do I execute that, right? That is a beautiful thing. And if you compare that against proxies, then this is actually the thing you want to have. And today, I'm delighted to announce Spring Data ahead of time repositories. Ahead of time repositories, if you switch them on during AOT processing, will contribute code that looks exactly as if has been handwritten by you. It gives you a place that you can step into your debugger with. And it moves all the heavy lifting query work into the build phase. And besides having beautiful code here, you get also a bit of performance effects. Moritz was already talking about AOT optimizations, right? And if you enable AOT optimizations, then you get already a pretty awesome performance. Enabling AOT repositories with JPA reduces your application startup time by another 10%. And if you went for Project Leyden with this 1 second startup time, enabling AOT repositories, you get consistent sub-second startup times with JPA. And I think this is pretty exciting. On the memory side, we are a little bit lighter. There are still effects after the first startup. You get around 10% less memory usage. But once you run the very first request, memory size increases a tiny bit, but it's still below the JVM baseline. Now, the beauty of AOT-generated repository code is not only that you get an awesome debugging experience, but you have to connect somehow also the dots. Just having that generated fragment needs to have to be wired into your application, meaning that if you run your application in AOT mode, those fragments are being used. But that doesn't really help us with debugging yet. You need somebody like Spring Tool Suite, like IntelliJ, or your other favorite IDE, to pick up AOT repositories and make use of that, make something sensible inside of the IDE. And that is what the tooling teams are actually up to. This is a screenshot of Spring Tool Suite for VS Code, and it is showing you the repository view. With AOT repositories, you get immediately displayed the relevant query for your repository queries. It can take you directly to the implementation, and it can help you also with debugging. All this is going to ship in November, and you can try out already milestones as of today. Tomorrow I'm going to talk about AOT repositories and other Spring Data 4.0 features in my session. And we will also discuss briefly Spring Data 3.5 features that have shipped Friday last week. For instance, we will go over MongoDB aggregations and have a look how you can use Mongo's aggregation framework to run vector search queries. And I think I mentioned something AI technology related, but I'm not the right person for it. Did you actually know that Josh's dog is doing AI recently? That's crazy stuff, right? And so I would like to invite Josh and Mark here to the stage to tell you more about Spring AI. Now, give it up and help me welcome Dr. Mark Pollack and Josh Rapidocoder Long. Where are you guys? Okay.
Look at that.
Selfie?
Yeah, we gotta do this. Let's put this thing over there, though. Let's see. Oh, somebody left their laptop. Okay. You think anybody's gonna mind if I just...
I would close it.
Oh, something just turned off. It's probably fine. Okay, so let's turn this on. Okay. Who knows what will happen? Okay. Yes, please. All the help I can get. Okay. Moment, please.
We check the audio.
Testing.
Okay.
Can we check the audio?
Yeah, this?
Maybe play something, but
Well, they can see my screen. What should I play?
go to YouTube video if you're on.
YouTube. Not so much.
No, see? It's okay, it's okay, it's okay.
Can they hear it?
Yeah, we have it.
Okay. Okay. All right. Oh my goodness, we did it. Okay.
All right.
Look, I'm really excited. We're here. Okay,
Me
I'm
too.
really excited. But before we get too far in the way, who knows what we have to do? Thank you. Thank you. Okay, come on, let's do the thing.
Oh, God.
Come on, hurry up, hurry up, hurry up, hurry up. They're gonna like kick us off stage if we don't hurry. Okay, you know the drill, everybody. Just pretend like you're happy. 1, 2, 3. Sonría. Wait, no, hold on. Okay. Open source. Oh, that's so good.
So nice.
Thank you so much. Oh, Doc, I'm so excited. I'm Josh, and this is Dr. Mark Pollack. Dr. Mark Pollack to his friends, Mark to the rest of us. So, yeah.
So, what's
Super
going on this week?
Super exciting week. I mean, my goodness. First of all, obviously, Spring Boot 3.5 comes out today.
Awesome.
Big deal, right? I love Spring Boot 3.5. Well done. Super exciting. And there's a new Mission Impossible movie.
Yeah, some
coming
AI
out.
in it.
Yeah, it's. Have you heard about they had a movie, and this is like the sequel, and it's all about this rogue AI that threatens to upend the world order. You know, it's probably fine. Anyway, there's
Something else, right?
There's something else. Yeah. There's one more thing. One more thing. Ah, so good.
Nice.
That actually happened. That was 2 days. Was it 2 days ago?
Yeah.
Yesterday?
May 20th.
May 20th. Right. 5/20 of the 25, whatever. I don't know. Of this year, we released Spring AI 1.0 after how many years? 2.5 years.
Something like that.
Congratulations. That must have been.
Awesome.
Oh my goodness. That's incredible. And long time in coming. I think it took a little while because, well, the AI space doesn't exactly stay still, does it?
No, it does
No.
not.
Okay. Well, good stuff.
Get me in presentation mode here.
Okay. Command Enter. Do the thing. Next. There we go.
There we go.
Right arrow, maybe.
Ooh, right arrow, left arrow.
Fancy.
So yeah, it was released finally. It's very difficult to release GA on a moving target like this, but we managed, and with a lot of help. I've curated the commit logs, and we have about 250 people who really contributed. Something small, something very big, but really, for me, quite humbling to see all the input from so many people. And we provided a series of foundational building blocks to support you building generative AI apps. And these kind of a laundry list of what's become standard over the past couple of years in the industry. Bringing data to the app through retrieval augmented generation, keeping chat memory so that it's a stateless API, but you're able to then keep bringing back to that stateless API the conversation. Tool calling, how to have your APIs be invoked by the model. Tricky bit, more science, more art than science, is making sure this thing works, right? How to evaluate the effectiveness of your app. And last but not least, making sure it all runs safely in production, how much it's costing, how you debug things. And these feature set really came out of what are the challenges with the technology and what are the solutions. So the solutions are pretty much what I just showed on the last slide. But the challenges were, it's not aware of your API, so they created tool calling, limited context size. We've come a long way in the space that the AI models have to operate on your own data. Originally started off with the equivalent of 4K words, right? Kind of like 8-bit microcomputers. Now we're up to, essentially the standard being, 100,000K, even, 1 million K. Pretty impressive achievements there. And, not trained on your data. Vector stores, key component. We support over 20 vector stores, over 20 different models, all through one single unified API. And the sort of architectural pattern has emerged over these years is what Anthropic has dubbed the augmented LLM. That's kind of the terminology I like to pick up here. It's basically your prompt comes in, and there are all sorts of techniques, prompt engineering techniques to make a good prompt. But it's not just going in straight to the model and coming out. It's augmented, right, with all of these features. Basically, how do you retrieve data relevant that the model doesn't know about so it can reason over them? How do you call APIs and tools? And how do you keep the memory of previous interactions? So this really is the building block now, this pattern. Typically, you'll have all 2, potentially 3 of these components augmenting what goes into the large language model. But now we're in generation 2, right? We have new challenges. So how do I share all this stuff across an ecosystem? You know, Spring AI is a framework for AI application development in Java, but there are others in other languages, right? It's going across the entire ecosystem. Python, of course, being probably the most predominant, but Golang, you name it. And when you start to look at this problem, it's really a classical N/M integration problem. And this is where Model Context Protocol, also created by Anthropic, comes into play. It helps solve this problem, and we'll talk a little bit more about that. And now, architecturally, how do you combine these building blocks, right? You have more than one, and they have to interact with each other. And this is where you come to the role of agentic patterns, right? And we have many of them implemented in our examples repo. You can take a look. But, you know, briefly speaking, what Model Context Protocol lets you do is connect diverse AI applications together, right? And it defines the domain space of this, and it can be done over HTTP, it can be done over standard I/O. And what you have is essentially the LLM on the left-hand side, your app in the middle with clients, and now they connect to servers. And this is sort of a universal USB-like connectivity. But it's not just data that's flying over the wire, it's really data related to specific content, domain objects, right, concepts. So tools are the big one, right, lets you do stuff, but it's also resources, meaning you know, what you might want to retrieve, prompts, kind of like a mini prompt catalog. And on the client side, you can have MCP servers actually invoke your LLM, and similar, you can expose routes, which is like exposing things on your file system. So there's a lot of richness here. It's super plug and play. Pretty impressive achievement. It's taken off like wildfire. And we were very prescient, I'd say, to realize the power of this. Also, by the way, shout out to Daniel with his blog on connecting this, but connecting it with a secure way through OAuth, right?
Daniel Garnier-Moirot.
Indeed. And so we donated the initial implementation that we had of the MCP spec to Anthropic, and now we're listed up there as the Java SDK alongside all of the other SDKs. And that's the GitHub page. And really a big shout out to Christian and Darius, who have been leading this effort, also leading efforts in Spring AI in general. Really, from spec hitting the internet to implementation was about 2 weeks last November to December. And everyone's talking about agents, the year of the agents, as they say. And just want to give a very high-level view of what we mean by agentic systems, some taxonomy, maybe to help wrap your mind around it. They really are AI system, use LLMs, and they accomplish goals, right? And these goals can either be achieved through workflows or predetermined, or the Holy Grail, it just figures stuff out, right? And the models have gotten very good, and they're specifically trained now to plan. So you can give it a problem, and it doesn't give you an answer, it gives you a plan to get the answer, right? Pretty impressive training and pretty impressive feat that they've done. And so what's a predefined workflow? It's kind of an inside joke people have that agents are just LLMs in loops. Like, yeah, I'm sure all the data scientists are about to kill themselves from that description. But it's really true. You can have a code generator and a code reviewer, put them in a loop, and watch the code get better and better. It's quite impressive to watch. And we have examples of these patterns. There's 4 or 5 of them that you can check out in our examples. And then this is the sort of holy grail I was talking about. There's an orchestrator. It creates a plan calls out to various building blocks. So each box here, LLM call, is the building block I showed earlier. It synthesizes the result, and out comes your answer. And last but not least, one thing that we discovered over the past 2 years working on Spring AI is we had a lot of great pull requests. And we were like, wow, this is great, but it's kind of incubating, or it's an area that we can't easily support, like there are many Chinese models only accessible from China. So we decided to create a community organization on GitHub. And this is managed by our great host here, Sergey, Adib from VMware, and Thomas Vitale. Also, big shout out to Thomas Vitale, such a big contributor for so many features in the Spring AI. So it's very lightweight. That's the goal, right? It's Apache 2 license, and the modules that we have in there now are, you want to do a quick demo app, so you can use Vaadin for that. The Moonshot and Qianfan, I don't know, not very good with that. Pronunciation, the Chinese models. And then this is more like incubation stuff, right? Little added sugar to help you create MCP applications with annotations. And then, the holy grail, everyone has their way of doing autonomous agents. And last but not least, a curated list of resources, the awesome Spring AI README. And with that, I will let's take it over to Josh to demonstrate, kind of the tools and patterns we have going on this past year.
All right, so thank you for that. If you were here last year, who was here last year? Okay, the rest of you did wrong. You did a bad thing, okay? You missed out. Last year, my friend Christian Soloff and I, we were on this very same stage, and we looked at the incredible state of terrible dogs, okay? Look, I have a terrible dog at home, not the goodest dog, not a good boy at all, just the worst dog. His name is Peanut. And last year, we talked about another dog about which I learned during the pandemic named Prancer. And the reason Prancer was so interesting was back in the pandemic, Prancer's owner tried to find a new home for this dog, and she put out this hysterical advertisement for this dog. She says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, children-hating, animal-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home, right? And she continues, he was quiet and just laid on the couch, didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home, right? So she continues also saying that you can't live in an apartment or a condo unless you want him to ankle bite your neighbors. We already addressed the men and children situation. If you have people over, he'd have to be put away like he's a vacuum. I know finding someone who wants a Chucky doll in a dog's body is hard, but I have to try. And she signs off saying, oh, he's only 2 years old and will probably live to be 21 through pure spite, right? Doesn't sound like it sounds like a bit of a handful, right? The very spicy dog indeed, but very cute, right? Very, very cute. Like, I'd totally pet that dog. That's a cute dog, but evil, right? But evil, just like my dog. So I think about this dog a lot, and I'm not the only one. This dog went viral. So for example, here's the dog in USA Today, here's the dog in BuzzFeed, look at that doggo, and here's the dog in the New York Times, right? So the world learned about this dog, and we helped build a service to adopt that dog. Now I'm sort of wondering, day 2, we need to be able to follow up on this dog and kind of understand what he's doing and if he's causing any trouble, any mischief at home. Probably, right? So I want to build a little system here to support that. And, there's a class of AI applications called chat ops, right? Mm-hmm. And chat ops is basically where you use Slack and the like, and that's increasingly being powered and augmented by things like AI, right? Supplemented with AI. But remember, in French, the word chat is a cat. So there's no way we could do that. We can't have chat ops for something to do with monitoring dogs. We have to call it DogOps. So we're going to go here and create a new service here and start that Spring.io. And, the first things first is we need some configuration for this application. So we'll go here and we're going to create a new config server, a new Spring Cloud config server. And look, friends, we're going to be using Java 24. right? This is the only polite and appropriate use of any Java version out there. You could select all these ones, but I would never ever select these versions, ever, not in any circumstance whatsoever, unless you want to show people what never to do, right? Remember, Java 24 is here, it's amazing, it's fast, it's robust, it's secure, it's operations friendly, it's more performant, and it's just awesome, right? Remember, Java 24 is morally superior, technically superior, and mathematically superior. Java 24 is 3 times greater than Java 8, okay? That's a fact, it's a fact. So we're going to go ahead and hit enter. We're going to build a, thank you, it's a fact. Nothing to argue about there. Config server. Got the web support, hit enter. And this is going to be a microservice that just mediates access to a bunch of configuration so that I don't have to copy and paste configuration values from all the different services. And we're going to just stand this up very quickly here. So config server, @enable config server. By the way, I'm going to be a little slow as I work through this code today. I'm going through a bit of a spiritual journey, okay? I'm learning Vim motions, okay? So I'm moving very slowly, okay? I'm just trying to say, just bear with me here, okay? So here's the Git repository that actually contains the configuration. We want this to run on port 8888, and we've inserted that it's a config server. There we go. Now we need to actually have the thing that'll detect the presence of barks. You know, how often is a dog barking? So go back to the lab again, start.spring.io, and here we're going to create a service called Bark Detector, and we're going to have the web support, we're going to have the config client support, we're going to have the Spring Boot actuator, we're going to have OpenAI, though there are dozens of different models and you can choose from any of them. We'll use OpenAI. We're going to use the, what else do we need? MCP client support, thank you. And I think that, GraalVM native image support, surely.
Config client. Yeah.
We got the client, we got OpenAI actuator, config client, web. It's probably fine.
Seems kosher.
Yeah, well, it'll be okay. So hit enter, go here, open this up, okay, barkdetector.zip, okay. And what we're going to do, first things first, connect this to the just installed config server. There's that. This application will be a simple application that allows us to talk to a model to ask questions about the state of the dog. So you can imagine having a REST controller like this, and it'll be called DogOps. There we go, DogOps controller. And we're going to have a constructor. Sure, and get rid of that. And I'm going to inject here, the first things first, is I'm going to inject the actuator meter registry, okay? And I'm going to use that because I want to create some counters to keep track of how many alerts we've been given related to barks, okay? So alerted versus received. We want to make sure that these numbers are being tracked at all times to make sure that the dog is okay, right? So we've got alerted equals registry dot counter dot barks dot alerted, yeah, and then we've got this one. And this one's going to be Vim motions, by the way. So there's that, and then it's received, and we say received, okay, received, and you can imagine, you know, we might have something down here where we say void receive whatever, something like that, and we can do some kind of test where we say, okay, this dot alerted dot count is greater than a threshold. Well, what is that threshold? That threshold is a value that we're going to get from the config server. So let's just comment that out here. And the config server, of course, you know, you can talk to it through the value annotation or through the environment or through configuration properties, whatever. So I'll say var threshold, yeah, threshold equals environment.getProperty barks.threshold alert or alert threshold. Alert threshold, and it's going to be a float, right? And we want to make sure that whenever the number of barks you know, per second or whatever, exceeds a particular threshold, that we alert, right? So threshold, okay, and we'll print that out. Okay, great. Now, we have this information. We want to create a little AI-powered endpoint to support asking questions about the environment. So DogOps, and we'll have a, you know, DogOps like that. And now we're going to use the chat client here. This is the Spring AI sort of central interface for all interactions with the chat model, which, by the way, I have already configured on the class path because I selected that starter. I also have the OpenAI key in the background. I exported that as an environment variable, okay? Forgive me for not leaking my API credential. Just trust that it's been done. Okay, so we've got this AI thing.
No, that's the builder.
Builder, that's the builder. Yeah. We're going to say chat client, private final, chat client AI, and we'll say this.ai equals AI.build, right? And what do we want to do? I guess we want to say return this.ai.prompt. We're going to take a request from the user, right? Request param, string question even, question. Here we go. Oh, come on. That is so sad. That wasn't even Vim. That was just me.
Ubuntu, I think.
Yeah,
right?
exactly. Okay, so content, good. Okay, so now I've got the AI model integrated into my application, But I want to give it access to the metrics so we can understand what's happening there.
Yep.
We can use Spring AI tool calling, local tool calling. So I'll create a description here. We're going to create an endpoint that returns all of the names of the metrics available to us here. And we're going to do that in terms of the metrics endpoint that gets injected automatically created by actuator there. So we'll say endpoint. Did I assign it to something? I did not. That is so sad. Here we go. Oh, Vim motions, by the way. Metrics endpoint. Okay. Here we go. Add that to the constructor again. Delete it here. Goodbye. Okay. Look at that. Vim motions. Okay. So now go back down, and I'm going to say return endpoint dot get list names dot get names. Okay. Perfect. And then I also want to be able to get the particular value of a metric. So we'll come back to that as well, and it'll be a collection of metrics endpoint dot sample metric values. Okay. String metric name, and I'll export that as a tool param like so. The name of the metric. Okay. And the idea is that we're going to give the model agency. We're going to give it the ability to actually execute things on our behalf by talking to the environment around it. Okay, and that's what we're doing here. So it's the metric name, list.of, okay, and then .get measurements. Okay, so now what is this going to do? This is going to return all the metric names for the bark detector application. That's this, and then this will return all the value for a particular metric. Right? New line. Probably fine, but we don't want to waste tokens, right? Okay, there we go. All right.
Stingy.
Yeah, so now we've created those tools. Let's make them available to our model in the constructor here. We'll configure access to a default tool, which is, in this case, just this, right? Okay, so if I restart that, we should see what? We can ask questions of the model about the state of things, right? Actually, I just realized, to simulate a failure scenario, let's just hard code these values. We're going to increment that to 1, and we're going to say that received is 2,000 or something like that, right? So that means we've gotten far more barks, but we only registered them and alerted on just like a very, very small fraction of them, which is a problem. So let's now go ask our model what's going on, right? First question, to the DogOps endpoint. Give me the value for all the metrics with the word bark in it, okay? Here we go. 1, 2, 3, maybe. Okay, so it's given us the value there in the metrics from the Spring Boot actuator, from the model. I'm talking to an AI model and I got access to my data. Nice, right?
Sweet.
Super good. Now, we know that this is a problem. That tells me that there's something wrong with the alerting threshold,
Yeah.
right? So that's in the config server, right? Well, how do we talk to the config server and get access to it and give access to it to our AI model? Well, we can use the aforementioned MCP support, right? There's a whole Cambrian explosion of unique possibilities around MCP. The Spring AI team has worked really, really hard. Congrats to you and the rest of the team on this. But this all came out last November, and the team, they were working super hard on this, and look, it took a toll. Okay, it took a toll. It's not easy to do this kind of stuff, very, very quickly. So, I hate to do this, buddy. I'm sorry. This is a photo of Spring AI lead Christian Soloff before the MCP effort, and this is after, right? Very, very, very sad. Just very sad. Very sad what the stress of these projects.
So much hair down the drain.
So much. His hairline receded 200 centimeters. It's terrible. Just so sad, right? So anyway, the point is, we want to integrate that config server. The Spring Cloud team has built an AI MCP service that allows us to do that. So it's not yet GA. It's a work in progress for sure. But let's go ahead and change the config server here and copy and paste that dependency. Go over here. Go to the pom.xml, and let's see down there. Paste. There's the dependency. That's all I need to do. I just need to restart.
Thank you, Ryan Baxter.
Thank you, Ryan Baxter, for that amazing work. Yes, thank you, yes. And we want to now make our existing code aware of that. That's a remote MCP service. So I'm going to use an MCP sync client. This is for the config server, okay? And I'm going to create an MCP bean here. MCP sync client MCP client dot sync HTTP, there you go. Transport HTTP localhost. Remember, the config server is running on port 8088, right? Build, okay, mcp.initialize, and then return MCP. There's that. Now I need to tell our model to talk to that for access to more tools being provided by the the Spring Cloud config server. So I'll just inject that here. This will be a default tool callback. I'll say config MCP, and it's a new sync. There we go, config MCP. And that's the only thing I'm going to do. I can restart it now. It's got access to new things that it can answer, new toys it can use to answer questions for us. So let's get it to answer the next question, which is, what is the state of our configuration? So here we go. 1, 2, 3. What are the environment variables for the main label for the bark detector application? Remember, this is a REST API that serves configuration from a managed GitHub repository, right? Or Git repository.
That one.
That one, right there, this Git repository. And the value is 0.09. No wonder we're not seeing almost any of the alerts. The value is too high, isn't it? It's too high. So what we need to do is to lower the value. This is stored where? GitHub, right. Well, turns out GitHub also released an MCP server, right? So this is another Lego brick that we can use. Let's go ahead and pull that in as well. And this one's going to be a local standard IO based version. I can do that here. I can say Spring config servers, okay, home, desktop, mcp.json. And this is it's a JSON config file. I've got it running over here. There's a personal access token way over there, but I'm not going to show it to you because, reasons. But this is the file that Claude Desktop pioneered, and we support it here. So now, let's go back to our code and then link in the tool callback provider. Okay, so tool callback provider, GitHub MCP, and then we'll pull that down, and that goes in the middle here, so default tool callbacks, github.mcp, get tool callbacks, and now we restart the application, having injected that MCP thing.
Sweet.
Let's try it out, okay? Let's try asking it now to help us fix things here. So this is this. Hello, come on. Vim motions, by the way. Okay, here we go. One more time. Set the value of bark.alert threshold to 0.1 in the bark detector properties in the GitHub repository called Josh Long Attic, blah, 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 Keynote config. And hopefully this will fix our situation for us. Okay, let's see what happens. So awkward.
There it is.
Okay, it's updated the value to
check it out
0.1.
on
Let's
GitHub
go
now.
see what that looks like. If we go over to our GitHub, this one, there's 0.9. Refresh. 0.1, right? As you can see, it was updated just now. 0.01. It's worked. We've updated the value. So that threshold will now trigger the alerting. We now have an end-to-end solution. We figured out how to change the alerting by pulling in these different MCP services and using the AI models to orchestrate things. I feel like things are good now, but we never did figure out the root cause, did we?
I'm not sure.
No, I don't think we did. We should ask the computer to tell it what it sees. Let's see what's happened here. Oh, it's Prancer. He didn't want to be caught. He changed the value.
Sneaky dog.
Sneaky dog. Bad dog. All right, well, this
Maybe
has been
Tom Cruise.
Tom Cruise. Yeah, exactly. Tom Cruise should adopt this dog. Hey, everybody. Who learned something new? Who had fun? All right. Thank you, everybody. Have a great day. Now, speakers, please come to the stage. We're going to do a quick selfie. All of you, bar the doors. You're not allowed to leave yet. Well, you probably can leave. Can they leave? Are they allowed to? Just say no. They can leave. You can leave, but not the speakers. Come on up, everybody. All the keynote speakers, get up here. Giddy up. Oh, by the way, while you're all trickling up here, there's a bunch of talks you should be aware of, okay? So, yeah, workshop, just all these great talks coming today, tomorrow. Oh, by the way, I want to say I also helped, Juergen, I helped with the representation from Austria, right? I brought Thomas Wertinger. Right, one more, right? I'm helping the numbers here.
That's it.
Okay, so, do we do it with the thing? Well, yeah. And more. Do we do it? Okay, hold on. Okay. Pretend like you're happy, okay? Okay. Bravissimo. Sorry, what? 11:05. What happens?
We come back.
We come back. We're going to come back here? In this room?
In all rooms.
Oh, okay. Everything
The
starts at
conference
11:05.
starts.
I don't have a mic.
Oh, okay. Yeah. I'm sorry. Brain is not good. Oh, thanks. It was all, it's all this guy. Well done to you. Thanks for being here. Super good. Let's see. Test. I'm off? No, I'm not. Oh, well. You, a great job. Let's get off stage.